Oirawa Seung-Jae from Seoul National University. Today I will introduce the global warming induced amplification of El Niño impacts on global sea surface temperature. As you already know, the El Niño to the connection is really important for subseasonal or seasonal climate, and also global sea surface temperature are affected by El Niño. Alexander, 2002, shows the atmospheric bridge indicating that ENSO-induced anomalous atmospheric circulation can affect to SST to the air-sea interaction, especially the anomalous latent heat flux, surface latent heat flux. In addition, there's many previous studies investigating the changes in teleconnection. For example, the eastward shift intensification due to the tropical precipitation response change. Thus, the El Niño impacts on SSTs are also expected to change under the global warming. Okay, use data is in-house CSM 1.2 model. That contains 28 ensembles. I compared the control experiment and 1% CO2 experiment. And to avoid single model dependency, I analyzed 34 models from CIMIC 6, pre-industrial, I used pre-industrial and 1% CO2 scenarios. First, I conducted lead-lag correlation with respect to Niño 3.4 and found maximum explainable variance from JJA to the following JJA to consider the regionally different time lag effect. As we can see, the El Niño impacts on SSTs are well captured in North Pacific and Indian Ocean and so on. In CIMIC 6 multimodal mean result 2, these results are quite similar to the observation results. So I can interpret the CSM1 and CIMIC 6 where it captures the ENSO impact on SSTs. In warmer climate, we can find the strengthened El Niño impact, and the difference shows more clear enhancement, especially the CIMIC 6 multimodal ensemble mean research depicts the global enhancement in every grid without any exception, and also this stippling indicates 90% of upper 90% of models agree with the sign of difference. To quantify the changes in global El Niño impacts on SST, I calculated the global mean absolute value of regression coefficients except for El Niño region. We can clearly see the enhancement of El Niño impacts on SST in global aspects. Also, if we look at the CIMIC 6 results, surprisingly, we can see the strengthened El Niño impacts over every CIMIC 6 models, and these results ensure the high possibility that El Niño impacts on SSTs could be strengthened in warmer climate. And then the next step, finding the main contributors. Among the various factors affecting SSTs, previous studies have identified the surface flux is the main contributor in most of the ocean basin. So we simplified the mixed layer heat budget equation and conducted the reproducible surface flux induced SST anomalies. And this figure shows the consistency with previous study, and also if we look at the difference, El Nino induced surface flux change mainly contributes to the El Nino impacts. In addition, we can decompose the surface flux down to two components: the only El Nino-induced surface flux effect and the climatological mixed layer depth effect. First, the MLD mixed layer depth climatology slightly contributes to the intensification of El Nino-induced SST. The MLD becomes shallower under global warming scenario due to the faster warming in ocean surface, indicating the stratification of ocean. So the ocean surface becomes more sensitive to external heat forcing. But the main contributor is the only changes in El Nino-induced surface flux. Yeah, so again, I decompose this to three terms: the radiation and sensory heat flux and latent heat flux. We can easily find components that showing the most pronounced enhancement, the latent heat flux. And why? El Nino-induced latent heat flux. Heat fluxes are amplified. To find the mechanism, I use the Berg formula from the Berg formula equation. The first factor is amplification of and so induced anomalous surface wind speed. Before that, the previous studies have identified the rainfall variability to the tropical rainfall variability to the SST will amplify in warmer climate, and this figure shows strengthened rainfall response in tropical Pacific. We can expect that this stronger precipitation can induce the enhanced atmospheric circulation in tropical Pacific and results in the stronger rose wave propagation. For example, this figure shows the El Nino-induced surface wind speed. We can find the westerly from the PNA pattern becomes more severe than present climate. And not only this region, if we see the difference of the magnitude, we can find that it is a global phenomenon. And the second one is the larger climatological air-sea specific humidity difference. Under global warming, the SST and surface air temperature will increase. Then, as the temperature increases due to the CC relationship, it is obvious that the saturation specific humidity, this QS, will increase more faster than air atmosphere specific humidity, like this figure, except for the SST cooling region. So then, the anomalous latent heat flux becomes more sensitive to the same wind forcing. In other words, anomalous wind can drive the evaporation more efficiently. It means even if the El Nino-induced surface winds are exactly the same, the El Nino impacts on SST can be intensified under global warming. Not only the global aspects of the regional analysis as done, most of regions can be explained by the previously explained mechanisms. For example, one of them, the enhances cooling region, US East Coast. The changes in DJF, El Nino-driven wind, show a stronger anomalous westerly, which is same direction of mean wind. The El Nino-driven wind can be US East Coast, SST, much cooler than the present climate. This is the last slide. As you can see in summary, the mixed layer depth shallowing and El Nino induced anomalous surface wind speed, a stronger surface wind speed, and climatological RC specific humidity difference can make the enhanced and so impacts on global SST enhanced. Yeah, this is thank you for your attention.
Thank you.
Okay. Thank you for the interesting talk. I'm wondering that answer amplitude itself might also change in under global warming. So does it affect your